Today we're going to begin with the first of 3 notes on magnetism. Magnetism is a very short unit, just 3 sets of notes. We're going to be taking an open note quiz at the end of the unit, so make sure your notes are up to date and ready to go in time for our open note quiz. Let's begin the notes part 1. You should have the part 1 worksheet in front of you that you're completing along the way. Magnetic force is the force a magnet exerts on another magnet, iron or a similar metal, or a moving charge. So this first bullet is what you're writing down for your definition of magnetic forces. Think about some things that are magnetic. Pause the video right now and please list 3 things on your notes that you think are magnetic. Alright, welcome back. Hopefully you listed a couple things that you think are magnetic. Anything that a magnet sticks to. A lot of times I hear metal. Some metal is, such as iron, and other metal isn't. Anything that a metal, your magnet would stick to, would be considered magnetic. Many people say your fridge. You put magnets on that. Okay, a compass works as a magnet. And there's many other things that I'm sure you listed that I didn't list here. If you have a question if these are magnetic or not, please feel free to ask me. Look at your person sitting next to you, exchange notes with them on what they listed as magnetic and what they didn't. Magnetic forces create what's called a magnetic field. Magnetic field is strongest near the poles, and it either attracts or repels. The poles of the magnets is right here. You've got North Pole and South Pole. You can notice that all these lines seem to line up right here. They come close together. And this is how we know it's strongest. Again, in the south, they meet here. Where there's more lines, it means the forces are stronger than when there's space. It either attracts or repels other magnets. Attracts means comes together. This is sticking pictures on your refrigerator with a magnet. Okay, the magnet is attracted to your refrigerator. Repel is to fight against. That feeling when you take 2 magnets that you take like south and south and you put them together and you feel like there's an invisible force you're fighting against, that is repelling other magnets. Electromagnetic force. Electricity and magnetism are all parts of the same force because both are caused by electric charges. Moving electric charges is what causes a magnetic field. We're going to talk about how this magnetism and electricity relates together in our next set of notes. It's called Faraday's law. But what you need to know right now is that it's moving electric charges that create a magnetic field. We have what's called the right-hand rule. There's many different versions of the right-hand rule, but we're going to talk about 2 versions today in this unit. You're going to learn more about this in physics. But right now, it's basic introduction. In order to understand the right-hand rule, I would recommend always having something to write with. It's okay to use that pen, pencil, whatever you have in your hand as a pole and point your fingers and thumbs in different directions. You are always using your right hand. That is the key to the right-hand rule. Okay, the first right-hand rule says if you point the thumb of your right hand in the direction of the current, your fingers curve around the direction of the magnetic field. So you notice here that the thumb of the right hand is pointed up, and this is the direction of current. Remember, I equals current. And the fingers wrap around like this, And you notice that this direction is the direction of the magnetic field, traveling around like this. Another way we can say this exact thing is that if you point the fingers of your right hand in the direction of the current, your thumb points to the magnetic north. So here, the fingers are wrapped around the direction of current, and the thumb is pointing to north. Let's practice a little bit of these. Alright. So, let's do our first one. Let's pretend that current is running up and down. And I give you a question where it's asking you to find what direction is the magnetic field. I'm going to take my pen, in this case it's a knitting needle, and I'm going to point my thumb upwards in the direction of current. And I'm going to wrap my hand around. And I notice that my hand travels counterclockwise around this pole. So I'm going to draw my arrows going counterclockwise around the pole. And I'm going to label this as magnetic field. I know you don't have these examples on your notes. If you want to make a little separate section for this on your notes, you can. We're going to be practicing this for the rest of class today. So I would recommend having a couple of these examples down. If not, you can always come back to this video and watch it again. Alright, let's pretend that magnetic field, or not magnetic field, our current is going this way, to the right. Okay, what I'm going to do is, I'm going to first pick another pen color, because the pen just started drawing on its own. I'm going to take my pen or pencil, and in this case on my knitting needle, and I'm going to point my thumb to the right. And I'm going to wrap my hand around. And I'm going to notice that my fingers are pointing towards me, so I'm going like this, in a circle in towards me. So I'm going to draw my arrow for my direction of magnetic field towards me, wrapping around. Okay? What happens if I reverse the direction of current? Okay, if I say current is traveling this way. So I'm going to take my thumb and I'm going to point it in my new direction. And I'm going to see that my fingers come up this way. Come up and around like this. So I am going to draw my magnetic field coming up, reversing the direction of the current, reverses the magnetic field. There might be a situation where I tell you that current is flowing around this way. And you need to figure out the direction of magnetic north. So I take my pole and I say that my current, I'm going to wrap my fingers so it looks just like the arrows. It's going around this way. And my thumb is pointing up, so magnetic north must be up. Let's try it in a different way. Let's pretend that my current is wrapping around down. in this situation, my current is wrapping around down. My thumb is pointed that way. Notice I'm always using my right hand, not my left hand. If you use your left hand, you're going to get the right hand rule wrong. Okay, my thumb is pointing this way to my right. So magnetic north must be to the right. What happens, do you think, if I reverse the direction of current? If I say that current is going up. You need to do this out fine. Okay, I hold my stick, I make sure my fingers go up, my thumb is pointing to my left. Many of you might be saying, Miss Duell, it's just the opposite. You said that if it was going down, it was to the right, so if it's going up, it must be to the left. And you're right. Alright, at this point, you should be done with your notes. You should know the difference between magnetic forces and how magnetic forces and electricity relate together. You should be able to list some examples of what a magnet is in a magnetic field. You should also be able to understand the two forms of the right-hand rule. We're going to continue practicing right now with magnets and right-hand rule practice. It has both a forum online and a worksheet. If you'd like to find someone else who's done with the notes to work together, feel free to work together on this worksheet as you practice this right-hand rule. Right-hand rule can be really difficult. The only thing we can do is just practice it over and over again and make sure you're actually acting out the process of the right-hand rule with your right hand. It will help you very much in order to get the answers right. Good luck!